So here I have in 61b, we're going to talk about normal distribution. And here I have kind of what that looks like. Before we go into normal distribution, there's one thing you have to understand. In order to have good data, in order to have enough data, you know when you've collected enough data for a normal distribution, your mean, your mode, and your median will all be the same value. They'll all be the same number. So your mean, which is your average, your mode, which is the value most used, and your median, which is the value in the middle, or the number in the middle, those will all be the exact same number. When you get the data to where those three all are equal, then you know you have enough data to have real study, to have a real distribution, and to be able to evaluate it. And then what that evaluation process tells you, if you have the smaller standard deviation, your numbers are tighter together. That means that whatever it is, the smaller the standard deviation, that means the better the process or the better the efficacy of that study. Not necessarily of the medicine or of the process or of the weight of the dogs, but of that study. And what that means is, let's say we go back to the veterinarian example where we weighed all of the dogs that showed up at the vet on one day, and there were only 4 of them. What if instead we weighed all of the miniature dogs that came to the vet in a period of 4 weeks? We'd have a lot more data points and a lot more targeted data points. We wouldn't have this huge range from little bitty baby dogs to big monster dogs, right? The data is more targeted and more specific, and your variation would be smaller. Your standard deviation would be a tighter function. So that you would have something that looks more like this. This is the graph that you want, because then that means that your study is more precise, right? You've got a better group of numbers. And you know you've got all the data you need to do that study when all 3 of these values are the same. So that's what I'm going for here. So standard deviation tells us that typically, this little number down here, the standard deviation, when we do a study of any kind, we record our data, 68% of our values will lie within 2 deviations of the mean, and that's 1 on either side of the mean. So basically, this yellow section here that I've marked out as our 68%, our mean, median, and mode are right here in the center, and we have 10 on this side. This is 1 standard deviation, and we have 10 points or a value of 10 on this side. So we have 2 standard deviations here like this. Same thing here. This yellow section, which is the 68% targeted area, this would be 2 standard deviations. So we would have 3 on this side and 3 on this side, and this middle line would be our mean, mode, and median. And that is, where we would expect the data to fall. And if it's a good study, that's where it will fall. And we want that to be as small as possible, because then it means our study is effective. We know what we're measuring, how we're measuring it, and we can see what's going on. So as far as the rest of the data is concerned, let me put a couple charts on here that illustrate the next level. So in the second chart, this is going to be where 95% of your values lie. So 95% of values lie within 4 deviations of the mean, or 2 on each side. 4 standard deviations, not just deviations, but standard deviations. So you've got 1, 2, 3, 4 of them here, and 2 are on the left side of the mean, median, mode, and 2 are on the right side. So that would be an additional, 27%. So 13.5%. Is that 13? Yeah, 13.5% more here and 13.5% more here, right? So you have 13.5, 34, 34, 13.5%. That's the way it kind of rolls. And that's, that's going to tell us some more stuff about, the data points that are there. And we're getting to a point to where we can almost eliminate some of these other points. Let me show you that chart. So finally, we get to a point where we can start identifying the outliers. And the outliers are going to be those that do not fall within 99% of the data points. So 99% of the data points are going to be within 6 standard deviations of the mean. That's 3 on each side of the mean. So we went from 95% being within 2 on either side of the mean to 99% being within 3 on either side of the mean for a total of 6. So any data points that fall outside of our 99%, we call those outliers. And that is going to be outside of the 99%. Now, typically, the outliers have some type of extreme. There's some type of special circumstance. Let's say, for instance, my standard deviation charts here represented the amount of time it took in seconds for, let's say this is an Algebra 3 student to factor a problem, 3 seconds for them to factor a problem. And let's say this is an Algebra 1 student. It takes them 10 seconds. Or the standard deviation is 10 seconds to factor a problem, right? The same problem. So that would be the average Algebra 3, the average Algebra 1, right? That would be their data rate or their standard deviation or whatever in regards to the speed of solving a problem. The outliers would be that kid in either class that's just good at math. Like they understand it. It clicks. They're brilliant, or that's that kid that's actually retaking Algebra 1 or retaking Algebra 3 just to keep their skills fresh. They already know how to do it. They're just redoing it for the sake of not forgetting because they're about to take the ACT or whatever. Well, then the one on the other side who's slower, that might be the kid who has dysgraphia or dyslexia or has some type of a challenge with factoring. That's going to be what we see. Those are what we call our outliers, and they're not what we consider average. They're not what we consider the norm. And so we disregard that data from those outliers whenever we look at studies. Whenever we make a study based on data points, we drop those from the study. And it's very typical to drop whenever you do, like when you're grading on the curve or you are examining data, to drop the highest and the lowest scores and just focus on the rest of the numbers that you are given when you are doing something that like analyzing data, especially if you're doing a target marketing. I know in focus groups, right? They rate a product. They'll immediately drop the highest score and the lowest score because of people's dispositions. You have people who are suck-ups who are going to just, oh, you're wonderful, it's lovely, I'm just happy to be here. You have those happy to be here people. And then you have those people who, well, yeah, I'm just here for the food. So I really don't like anything. I just want the snacks that they promised me. I'm just here for the paycheck or whatever it is, right? They're here not because they want to be, but because they have to be. And so they're going to be grumpy. So you automatically would drop off the best score and the lowest score and focus on the ones in the middle, because the ones in the middle are going to be the ones that actually are there because they find it interesting or because, they want to know more, or they're curious about how could this help me. So I know that's what they do when it comes to focus groups and target marketing and introducing products They always do a test or a focus group before they release it to see how the public's going to respond to it. And this is one of the tools that they use for that. They look at the normal distribution and see where the data points lie and how tight that standard deviation is. That is another thing that we need to concern ourselves with, is the size of the standard deviation in regards to, or in relation to, the data point values themselves. When we're dealing with small numbers, like seconds, and then we have, we're measuring things in seconds, but our values come back in minutes, maybe we're not measuring it the right way. Maybe we need to be measuring it in minutes. Maybe we're measuring the wrong thing. Maybe we need to divide the subset. Like, for instance, when we were talking about the dogs, when it comes to weighing dogs at the vet's office, instead of weighing all the dogs that show up, right, on one day at the vet's office, maybe we just weigh the miniature dogs over a period of 4 weeks instead of just one day, and we get much better data out of that. So you have to look at, how effective, what was the efficacy of the study and the data collected? How focused was it, and how realistic was it? When your data is really skewed and you have a huge standard deviation in regards to the what's being measured, then you need to take another look at that. So we have one problem to do for this section. So let me put that up here for us and we'll run through it. So here's our problem. 61.2. The mean of a distribution that is approximately normal is 100, and the standard deviation is 5. Tell how the data is distributed with respect to the mean. So we know, here's the mean. We can just kind of draw a little picture here. Our mean is 100, right? So if we go, let's just pretend these blocks are going to be a standard deviation, and that standard deviation is 5. Then we know that one standard deviation here, that's 105, and this is going to be 95, right? So given that, 68% of the data is 95 to 105. And all right, so now we have to do 95%. We have to do the second standard deviation. So that's going to be 110 on this side, and then that's going to be 90 on this side, right? So 95% of the data falls within 90 to 110. And then finally, for that third standard deviation on either side of the mean, we have 85 and we have 150. So 99% of the data should equal or fall between 85 to 115. And that is how we would explain the distribution given that information. We would just say 68% is between this range, 95% is between this range, and 99% is within this range. And that's all we really have to say. It's pretty straightforward when you give yourself a little sketch and you make sure you identify this is the mean, so that then you can count your deviations a little bit more readily, because then this will be -5, -5, -5, +5, +5, +5. We treat the mean like the origin of our number line. And that is all we have for 61B. So we'll have a couple little practice problems for you to kind of lock this down, and then we'll go into I think it's the final part of lesson 61. Yes, and we will discuss the ever fun box and whisker plot.